Everyone, this is problem 115 of chapter 3. So the first part of the problem asks you to solve for the direction at which the wind is pushing up on the plane, as you can see in this lovely picture I drew. So in order to do this, I broke my force vectors into my force vector into two components, x and y component. Use the same formula, F equals ma for both of them. It gives us the horizontal acceleration, so it would be the x-axis, 0.96 meters per second squared, and it gives us the mass of 2,800 kilograms. Solve for the f of x, it'll give us 2,408. For f of y, we know since it's in the vertical direction, it's just going to be the acceleration is just going to be gravity, which is 9.8 meters per second squared, times the mass, which would give us 27,440 newtons. So we take these two numbers. In order to solve for theta, we use our tangent. So as you can see right here, rearrange everything so you can solve for theta, and it comes out to be around 5 degrees of with the vertical y-axis. Alright, so for part B, it asks us to solve for new components where the angle theta is 2 degrees closer to the vertical. And yes, I know I misspelled vertical right here. But anyways, so here's our old force, the magnitude of our old components, and we can plug this old magnitude into our new equations. We're still using F of equals ma, but we got to figure out the directions at which our magnitudes are. So right here, this would be a of x times the mass, and we know f of x is just going to be, the horizontal acceleration, so we can just determine this, which would be sine opposite of theta, sorry. Solve for a. We're going to use our new theta value right here, sine of 3, and we get a of x equals 0.51 meters per second squared. So for the y component, we know the y force, the vertical one, is what's moving up, which is our old one, cos theta, our new theta value, minus the weight of whatever. So you plug everything in, your new theta value. Here's our old f component, our old f magnitude, minus the weight, and then you come out to be f of y equals 67.3 newtons. Now using this number right here, we could figure out the acceleration of the y component by just plugging in this with 2,800, and it'd come out to be 0.024 meters per second squared.